Good afternoon. I'm Miles O'Brien, Master of Ceremonies today. Welcome to Mars, and a whole new way of thinking about how and how soon human beings can explore the planet next door in person. The piloted mission to the red planet you'll hear about today is not the one that you've heard about in the past, the elaborate, expensive landing schemes that we've all become accustomed to thinking about. It's a mission that will bring two humans within 100 miles of the surface of Mars, a flyby. It's a lean, and over the course of 501 days, I am sure it will be mean mission. There are no technical or financial showstoppers that I can see. In fact, the beauty of this idea is its combination of simplicity, audacity, and liquidity. In fact, Dennis Tito has a track record of thinking big and out of the box, not taking no for an answer, and then making history. More on him in a moment. But first, a word on the whys. Why Mars? Why now? Our neighboring planet has always captivated us. It is my second favorite planet, and our thirst for knowledge about it has led us to some pay dirt in recent years. In my lifetime, we've gone from a vague sense that the surface might be etched by canals, ringed by Martian condos, to a keen understanding that while the planet seems lifeless right now, it was once warm and wet, and thus a cushy berth for life. Now, we know this thanks to a successful series of robotic missions that have orbited or landed on Mars. The nuclear-powered Curiosity rover is the latest and most sophisticated member of this armada. But as capable as these robots are, we are approaching the limits of science by remote control. A human geologist with a hammer and a magnifying glass may be the best way to finish solving the scientific riddle of life on Mars. But there are other reasons humans need to go there. If we don't seize the moment, we may miss the chance to become a multi-planet species. And sooner or later, humanity will cease to exist. There are always reasons not to do it. We can talk about the cost, the risks, and the rationale. Columbus or Magellan would never have left the harbor if they dwelled on these worries. Sometimes you just have to weigh anchor and shove off. And that's what Inspiration Mars is all about. Inspiration Mars is all about the first name. The goal is to inspire a sea change from talk into action. It is about inspiring our political leaders today to stop being timid and to fund a piloted mission that will get us to the surface. And if they won't do it, perhaps Inspiration Mars will convince their constituents or maybe their children that this is worth doing. Because the goal here is to send two people, but take everyone along for the ride. Now, the launch date is January 2018. That is dictated by orbital mechanics. But the mission happens to coincide with the 500th anniversary of the start of Magellan's circumnavigation of Earth and the 50th anniversary of the Apollo 8 mission that put humans in the orbit of Moon. So the planets are literally coming into alignment to make this happen, and so has a great team. Tabor McCallum is the CEO of Paragon Space Development, which designs life support and thermal control systems for commercial piloted spacecraft. He spent 2 years living and working inside the Biosphere 2 experiment from 91 till 93. He is the Chief Technology Officer for Inspiration Mars. Dr. Jonathan Clark is an associate professor of neurology and space medicine at Baylor College in Houston. He worked at NASA from 97 till 2005 and served as a space shuttle crew surgeon for 6 missions. He is the chief medical officer. And Jane Pointer is the co-founder and president of Paragon. She also was a member of the Biosphere 2 team. She's an expert on sustaining human life in a closed-loop environment. Which brings us to the leader of the team and the man who put the inspiration into this idea. He began his career as an aerospace engineer at NASA's Jet Propulsion Lab at the age of 23. While serving at JPL, he was responsible for designing trajectories, flybys, not coincidentally, for the Mariner spacecraft missions to Mars and Venus. In the spring of 2001, Tito served as a crew member on an 8-day Russian Soyuz taxi mission to the International Space Station. He was the first private citizen to fund his own trip to space. It was the realization of a 40-year dream for him, and he made some history. Today, he is Chief Executive Officer of Wilshire Associates, a leading provider of investment management consulting and technology services. And he is the founder and president of the Inspiration Mars Foundation. Please welcome Dennis Tito.
Well, thank you, Miles, for that wonderful introduction, and thank you all for coming. This is a much greater turnout than I would have ever expected. Of course, we're going to be talking about a human mission to Mars, two people, a man and a woman, and we'll talk about later why it is a man and a woman. And we will also talk about what was the motivation behind this study, or this mission. How did I get involved in this mission? But let me start out with making one thing clear. I will not be one of the crew members on this mission. And if I were 30 years younger, I still would not be, because the requirements are going to be so high, and you'll hear more about that. It's going to be quite a crew selection process. As Miles mentioned, I started my career doing flyby trajectories of Mars. I presented my first paper on a flyby mission to Mars at a aerospace conference in 1965. Sunday, I will be presenting my second paper on a flyby mission to Mars at an aerospace engineering conference. And the reason we actually decided to have the news conference is that since we were releasing this study, which we will talk about, to the public, it was appropriate at least to make these clarifications, because I know when the news first came out that we had some publication, that people thought that maybe I was going to fly on it, but sorry. Anyway, that 50 years ago, it was just a really exciting part of my life, and here we are, 50 years later, and I'm probably even more excited. And to go full circle like that is really, I regard it as a privilege. But let's look at our current situation in the space program. In my view, having started in the robotic side at JPL, we continue to make significant progress with the Curiosity lander most recently, the Hubble telescope, the Voyager missions to the outer planets. It's just been outstanding from a scientific standpoint. We have not made nearly the same progress in human spaceflight, particularly with respect to deep space. We had not sent humans beyond the moon in 40 years. I've been waiting myself, and a lot of other people my age have been waiting and waiting. And I think it's time to put an end to that lapse. Also, one of the things about our stated space policy is that our goal is to eventually fly close to Mars in the mid-30s. Well, I'll be 95 years old. I don't want to wait until that time. So how can we make this happen sooner? We need to do something innovative and exciting. We need to bridge the gap between the current ISS flights and the SLS Orion, which is our planned architecture for the future deep space human space flight. However, we cannot make this jump very easily. Spaceflight is very complex. There's a lot we have to learn. And the idea that we have is we need to have missions in between to gain engineering experience, to gain experience on the life sciences, on humans. How do humans behave when they get away from Earth? How do humans behave when they look out and see this pale blue dot that they can barely differentiate from a star? What impact is that going to have on the crew? We need to learn that before we actually send a crew to land on Mars. So let me tell you about my efforts over the last year and a half. I decided to go back to the future, reinvent my trajectory skills. I started reading books, programming trajectories on Excel, learned things that I never really understood even when I was doing it 50 years ago. And I got interested in the idea of lunar trajectories, possibly to fill in, that would go beyond the moon but come back. And after doing that for a while, I just started thinking, well, what about a Mars flyby? I'm really a flyby guy. So I went and I looked at the literature, and I found this paper. And I couldn't believe it. It was just too good to be true. And if you could put the slide up, it was a paper that was published by Patel, Languski, and Sims, and it was called Mars Free Return Trajectories. It was published in 1996. Now you can tell by the beautiful graphics, it's vintage, and we didn't modify that at all. And it looks like an ink blot test, from Psychology 101, but it actually shows on the vertical scale the flight times. And what you should notice is on the lowest 4 dots, they represent Mars flyby opportunities that are approximately 1.4 years in duration, approximately 500 days. And the time scale on the bottom, which is hard to see, you should know that the time between each pair of dots is about 2 years, and the time between the dots themselves repeats every 15 years. So the 2018 trajectory that we'll be talking about for this mission is the lower right-hand corner. And if you were going to extrapolate this graph ahead, the next opportunity would be 2031. Now, I like to use the expression low-hanging fruit for something that is easy to reach, the least expensive to reach, an opportunity. This perfectly depicts low-hanging fruit, those 4 dots on the bottom. And what we're suggesting is let's go for the 2018 opportunity, because the planets realign every 15 years, and who wants to wait until 2031? Because by that time, we might have company. It's a pretty easy mission, which I'll explain in a minute. Easy in its simplicity, always difficult because it's a space mission. You can see the diagram. This illustration was obtained from the internet. Someone picked up on our launch dates, was able to target the trajectory with their own software, came up with exactly the same numbers. So at least we know it works. And but they did a better job in the graphics than we did in the paper. So if you have a copy of the paper in the press kit, so you'll notice that this graphic is a lot nicer. So as Miles mentioned, we fly within 100 miles of Mars. I mean, that's essentially being there. It's just that easy to go out, swing by, use the gravitational shift of Mars, and come back to Earth, just like a boomerang. You don't have to have any propulsive maneuvers. It's really simple. Anyway, still wanted to make sure that, was this mission really doable? I decided to hire a team of experts to study critical areas to determine whether this mission would be feasible. And those areas were looking at the trajectory and payload requirements, life support, radiation, and thermal protection. We hired experts to work in all 4 areas. We spent 3 months doing a lot of work. We decided to put it together in a paper, again, which we're presenting on Sunday. And this paper, which is feasibility analysis for a manned Mars free return mission, actually provides the technical arguments for the fact that this is a doable mission. Now that the mission appeared feasible, where do we do next?